Hi. In this lesson, we are going to focus on acids and bases. That's our topic, acid and bases. We're going to focus on definitions of acid and bases according to Arrhenius, Brønsted-Lowry, and Lewis. Let's start from Arrhenius' definition of acid and base. According to Arrhenius' theory, an acid is a substance that dissociates to produce hydrogen ions, H+, in aqueous solution. According to Arrhenius, an acid is a substance that dissociates to produce hydrogen ions in aqueous solution. Molecule that dissociates to produce hydrogen ion or proton when dissolved in water is Arrhenius acid. Molecule that produces hydrogen ion when dissolved in water is an Arrhenius acid. Arrhenius acid is a substance that, when dissolved in water, dissociates to produce hydrogen ion as the only positively charged ion. That is Arrhenius. An acid is a substance that dissociates to produce hydrogen ions in aqueous solution. Now let's look at example. Hydrochloric acid, HCl, dissociates to produce hydrogen ion. This hydrochloric acid dissociates to produce hydrogen ion and chloride ion. The next acid is sulfuric acid. This is sulfuric acid, H2SO4. The IUPAC name is tetraoxosulfurous acid. Sulfuric acid dissociates to produce H+ and SO4 2-. Sulfuric acid dissociates to produce H+, that is hydrogen ion, and sulfate ion. The next acid is nitric acid. This is nitric acid. Produces hydrogen ion and nitrate ion. Nitric acid, the IUPAC name is triazonitrate 5 acid. It's a sweet in water to produce hydrogen ion and in aqueous. That is Arrhenius' definition. So this is hydrogen ion, hydrogen ion, hydrogen ion. Every acid is producing a hydrogen ion, which is the only positively charged ion. So HCl, H2SO4, HNO3, they are all Arrhenius acid. Hydrochloric acid, sulfuric acid, nitric acid are Arrhenius acid. They produce hydrogen ions in water. Let's look at Arrhenius' definition about base and base. Arrhenius base. A base is a substance that dissociates to produce hydroxide ions. Hydroxide ions, OH minus, when dissolved in water. When dissolved in water. So let's look at Arrhenius base. According to Arrhenius, so when you put a base in water, it produces hydroxide ions. Molecule that produces hydroxide ion, OH minus, when dissolved in water, is Arrhenius base. It is a substance that, when dissolved in water, dissociates to produce hydroxide ion as the only negatively charged ions. Let's look at an example. Potassium hydroxide dissociates to produce potassium ion and hydroxide ion. Sodium hydroxide dissociates to produce sodium ion and hydroxide ion. Calcium hydroxide dissociates to produce calcium ion and hydroxide ion. So you can see hydroxide ion, hydroxide ion, hydroxide ion as the only negatively charged. That is Arrhenius base. All these produces hydroxide ions. Let's look at Brønsted-Lowry. Brønsted-Lowry. Definition about acids. Let's look at Brønsted-Lowry definition about acid and base. According to Brønsted-Lowry, an acid is a proton or hydrogen ion donor. That is Brønsted-Lowry. An acid is a proton or hydrogen ion donor. A base is a proton acceptor, according to Brønsted-Lowry theory. Let's look at an example. According to Brønsted-Lowry, an acid is a chemical substance that donates a proton. A base is a chemical substance that accepts a proton. Brønsted-Lowry definitions of acid and bases does not have to be in water. Let's look at example 1. This example. Ammonia gas reacting with water to produce ammonium ion and hydroxide ion. Aqueous, liquid gas. Ammonia gas reacting with water to produce ammonium ion and hydroxide ion. Now, H2O, which is water, is an acid because it donates a proton. This is Brønsted-Lowry acid because it donates a proton. Ammonia gas is Brønsted-Lowry base because it accepts a proton. Look at it. Na3, this H2O. H2O. Water has donated one proton to ammonia gas. Ammonia gas accepts a proton from water to form ammonium ion. Ammonia gas accepts a proton from water to form ammonium ion. NH4. You can see it has accepted one proton. This is 3, NH3, this is NH4. Hydrogen has increased. Water has donated 1 proton. H2O, that when we come here is only 1 hydrogen. So water is Brønsted-Lowry acid. Water is Brønsted-Lowry acid. Ammonia gas is Brønsted-Lowry base. Let's look at the next reaction. Hydrochloric acid reacting with water to produce hydrozonium ion and chloride ion. HCl is an acid because it donates a proton. HCl is an acid because it donates a proton. Water is a base because it accepts a proton. Hydrochloric acid is an acid because it donates a proton. Water is a base because it accepts a proton. Here you can see water changing to hydrozonium. HCl has donated the hydrogen, and now I have chloride ion here. Hydrogen is not there. Here hydrogen has increased by 1, H3. Here is H2. So water has accepted. Water has accepted, and therefore it is Brønsted-Lowry base. HCl has donated a proton, and therefore it is Brønsted-Lowry acid. Water has accepted a proton, and it is Brønsted-Lowry base. Now let's look at the next reaction. Next reaction. Hydrogen peroxide reacting with water to produce hydrozonium ion and HO2 minus. Hydrogen peroxide is an acid. Water is a base. Hydrogen peroxide is an acid because it has donated a proton. It donates a proton. Water is a base because it accepts a proton.